Um, Good stuff. Yeah. So today we're going to talk about compression and all that entails. So, okay. Well, to start out with, get my notes here. To start with, compression is an often referenced and also misunderstood topic in music production. People talk about compressors a lot for different reasons. They are very useful tools and are used for certain important techniques, especially in electronic dance floor music, um, mainly for making things louder and sidechaining, like people are kind of familiar with, that they've heard about in music production, in the electronic world discussions. So, however, people also create a sort of mystique around compressors, like they're some special thing rather than just another musical tool. So keeping it simple and understanding that tool will mean you can avoid all of the hype and confusion associated with the topic. And so that's what we'll start with. So to start, what is a compressor? It is a tool that automatically adjusts volume based on certain parameters. In layman's terms, it's an automatic volume adjuster. It means it measures the incoming volume or signal. It measures the incoming signal and turns it down by a certain amount when it crosses a certain point or gets too loud. It can also turn the output volume up. And when you reduce certain loud parts of a sound, it like squeezes or compresses the dynamic range, or the range between the quietest and loudest parts of a sound, hence the name compressor. So to help understand this, we're going to use a few visual examples. We're going to walk through this. But just to start out, we're going to start out really simple and defining it that, yeah, a compressor, it's a volume tool. It automates volume based on certain parameters. And a good way to think about that is to help understand this, you can look at what people did in music recording studios before the invention of compressors. The first audio compressors were made in 1931 for radio and broadcast, with music studio use in 1950, and compressors made specifically for music use in 1959. So before that, in a recording studio, you would have a band being recorded into several different channels on a mixing console, right? Say vocals, drums, guitar, etc. The studio engineer would sit there at the mixing board and physically adjust the fader of the channel to maintain the desired volume output. Say if the vocals swell into an extra loud part in the chorus, they would adjust the level of the vocal channel then to keep it from becoming too loud. So a compressor automates this part of the process via signal detection. When a sound becomes too loud, quote unquote, it crosses a threshold and is reduced by a certain amount. So this is to show like what people were doing, and also what a compressor does by why it was invented and why it was created. Obviously, as music gets more complex, and it's just easier to automate things like adjusting the volume and maintaining a steady volume output. And yeah, this was done by hand in the past. Now, granted, music was a lot more simple back then. Like you may just have a few tracks, like the drums, vocal, guitar, etc., things to manage. Not like a whole bunch of channels in a modern music production. But that physical adjustment of maintaining the quote unquote correct volume of all the sounds, right? That's what a compressor was created for. basically, you can think of the first and foremost function of it, especially when it was created in uses like radio broadcast and other things, is that if a person is talking on the radio or music is playing and then it suddenly spikes in volume and gets a lot louder suddenly, they want to automatically catch that and, like I said, adjust the volume accordingly. So that is a simple concept background of what a compressor is, why it was invented, and so we'll start looking through those to show, to illustrate that more clearly. So to start with, we are going to look at a few different tools. Compressors, like most plugins, exist in many different forms. Every company and brand has their own compressor, and they are often and they all share the same principles and characteristics, though, that we're covering in the basics here. So to start with, I mentioned that the compressor is measuring the incoming signal level and adjusting the volume accordingly when it crosses a threshold. A good way to illustrate that is, okay, so here I've got a drum loop. Got a couple different drum loops just laid out here. We'll start with this one. And we'll open this Pro L2 limiter. Now, this is just a good starting example because it's an easy visual reference where you can see the hits of this drum pattern here, the drum, the kick drum, the snare, and then these smaller hits in here that you can see here that are hi-hats and other percussive sounds. But as you can see, they're much quieter. But you can see the limiter here reacting to those hits. Let's start just by looking at that here. Turn it on. Okay, so we see these individual hits coming out here. And then the limiter's functioning a little bit different. We're just gonna come back to explaining that more later. But to start off with, you see this red line up here at the top. That is, in this case, consider that's our threshold. That's when you talk about a limit, a threshold, like the limit that's set for what is considered too loud. And as we turn up the gain of this input here, and we hear these drum heads crossing that threshold, you'll see it being reduced in this visible red here in the limiter. Okay, so you see that. You see how these drum hits are coming, they're crossing, they're being pushed louder, as you see, starting from 0. They're being pushed louder and they're crossing this threshold and being reduced by a certain amount. So that's the first part of this concept of automatic gain reduction. And that is an easy way to see it just in this visual interface on this limiter here. But we can also look at other compressor examples. Like here, this unfortunately doesn't blow up large, but here's the stock Ableton compressor here. And there are different views you can use to look at this. There's this view where it just shows meter bars here, the 3 of them. There's this one where it shows the compressor slope here. And then there's this one that shows the signal level. If we play this here, you get another visual similar to, I'm sorry, kind of blasting this a little bit loud. Just going to turn down our overall output gain here. I have a limiter on the master channel here, and I'm just using that to reduce the gain, the output. But going back here, as we play this beat again, you can see something similar to what we saw in the window of the limiter here, where you see these gray spikes down here showing the incoming signal level. I chose this very simple drum beat in this case. It's very easy to see and visualize. And then the threshold, as you can see, it's labeled threshold right here, is this blue line, which you adjust, which is setting that threshold where the volume is being reduced. If it gets too loud, crosses that threshold. So I'll pull that down here. And there you can see that yellow line there that is showing the gain reduction action happening as these gray spikes of the incoming audio cross this blue line of the threshold. So that's the first part. Compressor is automating the volume via incoming signal detection. It's crossing what is called a threshold that's being set. And when it crosses the threshold, gain reduction is applied to it by the chosen ratio. Now the ratio you can see here, that's this part here. There's ratio, this is set at 4:1. You can adjust it to different ratios, and that is adjusting how much the gain is being reduced when it crosses that threshold. So starting at a ratio of 1:1, you can see there's 1, then a little semicolon 1. At a 1:1 ratio, it's not reducing the gain at all. The ratio means that, say at a 2:1, if I put this at, say, 2, at a 2:1 ratio means that for every 2 decibels of signal over the threshold, 1 decibel is let through or crosses that threshold. So say if I have my, what are we at right now? -15. If I have it at -16 and I play this beat with a 2:1 ratio, and then you see these spikes in the beat crossing that threshold, and that means that at the threshold of -16 dB, for every 2 dB that signal crosses the threshold, 1 will be let through. Now you can increase that. Now if we turn that up to 4, like a 4:1 ratio means that, for every 4 decibels over the limit, only 1 decibel is let through or played over that threshold. So the higher the ratio of compression is being applied, the higher amount of gain reduction is being applied to that. And at a ratio of 10:1, 10 dB over the limit for every 1 decibel of increase. Anything 10:1 or higher is considered limiting. That's what a quote-unquote limiter does. That's where you see this one we were looking at before. A limiter is a compressor, but a limiter is something that uses a very high ratio of at least 10:1 or higher. They are often using a ratio of infinite to 1, like this one. If we turn it up to the maximum here, it just goes up to INF or infinity to 1. That means that no matter how far over the threshold that signal goes, it's never being let over that threshold. So that's where a limiter is doing what's called clipping the sound, where it's clipping it off. It's not letting it come through a little bit like in the other compressor ratio. It's just cutting it off. It's also called like a brick wall limiter, or just clipping, where it clips the signal. It just does not pass above that red line. Like we saw here in this example. If I turn that back on, we play it, I turn the gain up. Now, because of the way this limiter is functioning, where it's not crossing the threshold, you don't see the signal going over the threshold like you do in this compressor down here. But you can see that, it's not crossing the red line of 0 dB. So a limiter is a compressor with a very high ratio, at least 10:1, very commonly infinite to 1. So the ratio is the amount of gain reduction that's being applied to the signal when it crosses the threshold range that you set. And when it crosses that range, so switching back to our other view here in the stock Ableton compressor, you can see this yellow dot here. that you can move around. And you see as I move that, it changes the threshold. This is the threshold, and you can see there's a slope to it there where you can change that angle of that slope. That's what's called the well, that's the angle of what's called the that slope. That line there is the ratio. You can see that example of where if the ratio is down 1 to 1, meaning it's not reducing the volume at all, if it crosses that threshold, you can see the line just goes straight. It just passes straight through. And as you increase the ratio, you can see that line sloping off there, showing how a visual example of how as that signal crosses that threshold point here, it gets reduced by the ratio like it's shown in that slope. And if you turn it all the way up to infinite, you can see it just slopes off flat, meaning it's not increasing at all up past that threshold. There's a good picture ahead here. Yeah, here this illustrates the ratios crossing a threshold. So yeah, as you can see, 1 to 1 here, it's not reducing the level at all. It's just crossing the threshold straight. 2 to 1, it's reducing it by half, 2 dB, for every 1. And then 4, and as you see, as the ratio increases, it gets steeper and steeper down to infinite, or a clipping, or a brick wall limiter, whatever. It doesn't allow the signal to get louder at all past that threshold. It just clips it off there. So yeah, that is understanding that first function of a compressor. And then, as mentioned before, so you can imagine that is the equivalent of like how much you would turn the volume down when things get too loud, in like super layman's terms, like that. And that's where those adjustments are made. And then the other part of that is what's called the knee. That's down here. Now the knee is the slope or sharpness of that ratio being applied. You have what's called a soft knee that applies the gain reduction more gradually. And it's kind of, it's harder to see because it's smaller plugin window, but this is a good visualization of it here. I've got other plugins, other ones, but this visualization of it is just really clear here. And so you can see this curve, this slope here of the blue line that is showing the sharpness of the knee, and you can see the adjustment for it here. Now, as you turn the knee up, you can see it get smoother and smoother, more of a curve. And that means that as the signal passes that threshold, the ratio is applied more gradually, more smoothly to it. And this is done, this gives the compression action a more transparent sound, a more like invisible sound. That's very smooth and musical, versus a hard knee. If you turn the knee down, you can see that curve and that slope becoming more and more sharp until the knee's down to 0. And it's in dBs as well. That means that at 0 dBs, once it crosses the threshold, the incoming signal crosses that threshold, it has 0 dBs to activate the compression ratio. So it happens instantly, and as you could see, there's a sharp line here. It just goes sharply from the incoming signal to the ratio we have set there. And as you turn it up, say if you turn it up to 2 dBs, well, that means that there is 2 decibels worth of transition crossing that threshold point to activate the ratio of the gain reduction. So a harder knee is a more aggressive and quick application of the compression, and a softer knee that's more gradual and smooth is a smoother, more transparent sounding effect, and obviously applies that gain reduction slower and smoother than having a hard knee set at a lower value. Okay. So the compression part of squeezing the signal I mentioned before, the term compression comes from the fact that you are playing a sound source here and you are reducing the loud points via a certain threshold you have set. And so by reducing or turning down the volume of those loud points in the sound, you're reducing what's called the dynamic range between the loudest parts of the sound and the quietest parts of the sound. You can see like these hi-hats here, in the beat are very quiet compared to the rest of the beat here. And so that's the dynamic range, is the range between the quietest part of the sound and the loudest part. And so as you are setting a threshold and then reducing the volume of the louder parts of the sound, you are reducing the dynamic range, the range between loud and quiet in the sound, and therefore you're compressing or squeezing that dynamic range, basically. Kind of a way to visualize that is, you see, I'll just take this audio clip here and I'll open it up here and just turn up the gain here, just turning up the gain of the clip itself. And as I do that, I turn it up, and then you can see, we'll zoom in here, make it even more obvious. As you zoom it, as you see here, you see the middle of these stereo files we're looking at. Now, these are all stereo files here with two images here, left and right. And there's an invisible line down the middle that is the zero crossing, or zero, or the top of the meter, the top of the channel, the top of the channel fader, the zero output level, like this. That is in the middle of these two stereo files here, these two stereo audio sounds. So if we turn it up there, if we turn up the gain of that file, we can see the loud sounds will start crossing that zero range. And as you can see, they start to get clipped. I mean, it's a digital meter, so it doesn't go over, it goes over zero, but it clips the sound at that zero level. And so that you can see it being literally cut off, flat here. If you zoom in, you can see it being cut. You can actually see the top of the wave, top of the sine wave there being chopped off and cut there. So that is like a visualization of what is happening with compression. This is like what's happening with limiting, where you're not allowing the sound to go over that limit at all. But you can see in terms of what it looks like reducing the dynamic range. You can see when we're starting out, here are those hi-hats, and they're down there, these tiny little waves down here that are very quiet compared to the big, waves of the loud drums. But as we turn that gain up and we clip those loud drums, we turn it up and up and up and up, and then look, the quiet sounds before are getting louder and louder. So now we have much less dynamic range between these quiet sounds and the loud sounds, because we've pushed this up. We've pushed this up, quite a bit, obviously, just to illustrate the point. But that's the illustration of dynamic range, where this quiet sound here versus the loudest sound here, but then it's the louder sounds are being, they're being gain reduced. The volume is being reduced there at this point. So the range between here and these quieter sounds down here is reduced, and therefore it's like you're squeezing the range from high to low down. So that is the compression part of, that's why it's called a compressor. And that's why people talk about things like smashing a sound, or like fattening a sound or something, or doing that, because you can essentially do that kind of thing where you're boosting a sound up to make it really loud, and making the quiet parts louder and clipping or reducing the loud parts like that. This is totally smashing it, but yeah, that's the compressing part of the compressor. And so yeah, and you can see differences in different beats. Like this one has the kicks and the snares pretty kind of maximized, in a way. They're almost, they're pretty close to that 0 point here, you can see in the middle. But then take this beat, for example, this one, you can see there's a much larger range in the middle here, between, all the drum hits like this. So And then here's like a drum and bass, type beat that already has compression and limiting done to it. And when you can see that square cutoff of the drum samples here, you can see that square part where they are chopped off here at the 0 crossing, and and you can hear them that loud. And you've got that very loud, compressed, maximized sound to that. So, okay, so we're talking about dynamic range and the idea of compressing the dynamic range. But here's the thing, dynamic range sounds good. It's what sounds musical and natural to us, because sound and music is not all just one loud volume, obviously. The difference between soft sounds and loud sounds is interesting and diverse, and it's what the world actually sounds like to us. So dynamic range is good and beautiful, and it's what sounds very musical and pleasing, actually. We can sometimes forget that in the world of dance music, where things are often loud. But that's for a different reason, because if you want to hear things clearly in a mix of music that will be played at very high volume in a big space on a huge sound system, the dynamic range is reduced, meaning things are never too quiet. Especially with some genres, sounds for the dance floor are made to be generally all loud and clearly audible. You don't have really quiet sounds happening generally in a, this is my streaming quality is unstable. What's going on here? Well, I hope the stream is still good. Streaming quality unstable. Why? Well, it looks like it's still going, but I don't know what's up with that. I'm still going to stream. The recordings posted, obviously. Yeah. Anyways, well, the point of dance music, electronic dance music, is that it's all generally loud and compressed because because quiet sounds don't translate very well to the dance floor. And so dance music makes heavy use of compression, of this ability to compress and reduce the dynamic range between loud and quiet, to bring things overall up to a louder volume and have a more stable, loud volume to all the sounds that it can then, that's where ideas like sounds punching through or cutting through a mix or something, or just, sounds being clearly audible, being heard clearly in a mix of music played at a loud volume. That's where that idea comes from. So that is also done using another feature of compressors, which is the output gain. So here you can see there's an output gain here, and that is adjusting the output volume, the volume of the signal that's coming out of the compressor. And so if you use the threshold and the ratio to really reduce, to reduce the volume of those loud parts of the sound and compress and reduce the dynamic range of the sound, and really kind of squeeze the dynamic range down, and then play it back out of the compressor at a higher volume too, then you're really boosting and compressing the sound output level. And that's that part is called expansion, as opposed to compression, where you're compressing the dynamic range. Expansion is it's a bit more technical than that, but expansion is where you are increasing the output volume of the sound. You're increasing the volume of it. And so that's where there are more detailed specific tools like compressors, expanders, compounders, shit like that. but just generally understand that you can not only be reducing the peaks and the loud parts of a sound, but also playing it back at a higher volume out of the compressor that makes those, it's like it makes those effects even more apparent, because you're making everything well, louder and easier to hear, but also from reducing the dynamic range and making the difference between like these loud parts and these quiet parts down here less, and so you can hear these quiet parts, you know, louder. This compressor and some compressors also have what's called a makeup. This is just an automatic makeup gain function. You can see when I click that, it automatically boosts this up a bit, and this will detect the output level of the signal in the compressor and automatically kind of try to turn it up to a steady output level. So makeup gain, there's an auto makeup gain button on this. There's also just labeled an output gain function here. Some compressors will just call that makeup. I think the glue compressor here in the Ableton stock compressor just calls that makeup, and that's makeup gain. That's just the output gain. Here's the threshold for the glue compressor. And the glue compressor is a style of compressor that is using a soft knee, like we discussed before, where the amount of the decibel threshold that has to cross for the gain reduction to be applied on the compressor, the knee slope, and a softer knee slope, like I said, is more of a transparent and kind of more musical sound. It's not as severe and aggressive sounding, and that's what a glue compressor is doing. That's what this term gluing the sound together is referring to. It's that it's kind of gently like you know, using gain reduction, and it's more than that. It's more than a style of compressor that is just referred to as this kind of gluing style glue compressor. But that's essentially what that is using a softer knee. But then you still have your same controls here: threshold, the output or makeup gain here. And then you have your controls here like attack and the release. And here's the ratio. We talked about the ratio before. The attack and the release of the compressor are just like any envelope. ADSR, the attack is, you know, how quick the effect is applied. The decay, or in this case, the release, is how quickly that effect is going away from the signal. So the compressor sense, it is similar to an envelope, where the attack, you can see this is in milliseconds. This is like in the middle is a one millisecond attack, down to the extreme end is a 0.01 millisecond attack, so like basically like no attack, and then up to 30 milliseconds of attack. So that is how quickly the compressor will engage when the signal crosses the threshold that is set. And then the release is how quickly the compressor will stop gain reduction once that signal is no longer crossing the threshold. So these are things that affect the characteristic of the sound that is created with the compression. And a good way to visualize that is we'll go in here and look at this sound. And I have this is an example made here where I just have a utility function, just the volume gain function here. And we'll look at the automation for the gain. Now remember back to what I was saying, that the original and kind of really basic way of understanding a compressor function is just like is that people used to literally just turn the faders down, you know, when things get too loud, and they would just reduce the volume of the channel. And so here we're doing that. We're just reducing the gain on this snare hit right here. See if we have this this kick and snare playing. Just go to this one. Here's the normal snare, you know. And then we have this gain reduction done to this one. So we're reducing the volume of this snare. Now, with this automation curve drawn here, we can see that this is just a good way to visualize. Like, so this, we are up at our normal 0 volume here in the middle, and then we're reducing it by 12 dB here. and then going back up to 0. So this is our compression happening. This slope here is our compression of the signal, let's say, happening. Now see, this is the attack. Like the snare hits here, crosses that threshold, and then we choose the attack, the slope, how quickly that gain reduction is applied. So this curve right here, this slope right here, of how quickly the gain reduction is applied once that snare signal hits, that is a visualization of what our attack of the compressor is like. We can zoom in here and see, okay, well, this is where it's right on the grid. This is where the start of the snare drum hit is. And then we could zoom in and we could look at that. We could highlight and select, click and drag and select an amount here. And then down in the bottom, down here, I can't see it when my mouse isn't there, but down here, you'll see that there is a time duration amount that'll tell you how many milliseconds we've selected. See there, that's 1 millisecond right there. That is 1 millisecond worth of time right there. We can zoom out and see that it's this little sliver, this very little sliver of time. But like if I put my point, there, like there, that's 1 millisecond of attack time. Now, what was this ratio down here? There's 1, there's 0.3, there's 0.1. So if we made that even quicker, like, oops, if we made that even quicker, like down to here, like that's, half a millisecond. It's so quick it doesn't even show you the timing down here. But yeah, that's the idea. And so this shows you what's happening when the attack of the compressor is hitting. And then you have your gain reduction, here along this line, while the whole sound is crossing the threshold. And then here, you can see kind of just, now this is just for, demonstration purposes, but like for illustration purposes, but you can see here, like once the sound gets kind of, it's loud for this part, and then it fades off, it's quieter in the tail of the snare here. So then, then here, that signal's no longer crossing the threshold. It's not loud enough in the tail. So then it fades back up to, the normal 0 level. So this part here, this curve here is the release timing. This is the release where once it crosses that threshold, it reduces it. And then once it's not loud enough to cross the threshold anymore, it lets go of it. And it releases the signal back up to normal level. So like this slope would be the release here. So it's, it's the same as an envelope principle. You have your attack, your A, and then your release here. This is like the sustain, basically, of how long that gain reduction is sustained. And then, it's released here. So yeah, another way to illustrate that too is using that limiter again, that Pro-L limiter, because you can see, I'll make this even bigger to see, you can see the attack and the release timings here. And then you'll see the slope of the red shading here that's showing the gain reduction of these drum hits. So if I crank it up here, so there, you can see how that red gain reduction fades in there, but it doesn't happen immediately. You can see that that red gain reduction, there's some delay because our attack here is set at 250 milliseconds. Now, if we turn that all the way down to 0, you can still see that there's some slope because of the reaction to it of the volume, but you can see that at the top here, right at the top at 0, it happens immediately. Yeah, like right there, you can see that that gain reduction is being applied immediately because the attack is down to 0. So, and the release then is, of course, like setting how quickly that, releases. If we turn the release way up, you'll see that, yeah, it really fades out, So you can see as you reduce that release time, it it reduces the amount of time that that curve of the gain reduction goes back to 0. So that's what those adjustments are. Look ahead. Look ahead is something that limiters have where it looks ahead of the signal a little bit by an adjustment. You can see you can adjust it from 0 to up to only 5 milliseconds. And that's if you want the compression action to happen ahead of time, because you see, back to this example here using the automation and the waveform, if we wait until the snare actually hits right here, and then apply even our half millisecond or 1 millisecond or half millisecond attack time, you see that there still is this little part of the snare drum, the transient, that is still coming through, not before the gain reduction, before the compressor kicks in. So look ahead is the function of basically going like this. Oh, no, not like that. Look ahead is essentially the function of taking that attack curve and moving it ahead, because what it'll do then is it'll see this signal here crossing the threshold, but then it looks ahead by whatever, point something milliseconds you set it to, so that it can do that gain reduction ahead and actually truly reduce the gain of that transient, of that really quick sound happening. So that's what look ahead is in a limiter. And remember, a limiter is a compressor, but not all compressors are limiters. So that is used in that case of the look ahead function, but in some cases you want the you don't want that look ahead. You want the slope to happen like it was where, you want that to happen like it was where there's a little bit of a gap, a little bit of a delay before the compressor actually kicks in and reduces the volume, reduces the gain. And that allows this little part, say if we had, this is still like, what do we got? Like 1 millisecond, 3 milliseconds right here. What if we had an attack slope of 3 milliseconds? Well, that allows this part, this just little part of the transient of the snare to come through without gain reduction, which preserves that loud transient spike right in the middle. And sometimes that's used in cases with drums and percussion, to preserve that. You still want to gain reduce the, the over, like you still want to be clipping the snare, for example, if you see that here. And if we have the attack set up a little bit here, to whatever, 20 milliseconds, you can see that the look ahead not set. Point is that with a longer attack time, it will allow some of the transient of something like a snare drum or a kick drum to punch through and can just help maintain some of that volume, that punch, initially. And you can see that with the slope here. You're still allowing a little bit of the transient to come through before the gain reduction. So anyways, that's just details. So yeah, compressors. Let's see, going back here. So yeah, when it comes to using that compression or that squeezing of the dynamic range, that reducing of the dynamic range, and then boosting the output volume is very common and used in electronic dance music to make things good and loud so that you can hear them clearly on the dance floor and stuff. But therein lies the danger. If a sound is heavily compressed and then expanded or played back at a high volume, it can destroy the sound quality and make it sound bad because it lacks any dynamic range and is just loud. And as we all know, loud noises don't actually sound good to our ears, So there's a balance with that, where you can smash a beat and make it louder. Like you can hear in this example. See, we'll listen to this with no compression, no glue compression. We'll just, we'll use the limiter again because it has this nice visual to it, that you can see. But we'll use that, and we'll play this beat back first with nothing to it, and listen to the kicks and the snares that are plenty loud, but then listen to the hi-hats, Or it's actually more like a shaker, whatever, or something. But it's very quiet. So okay, let's compress it. Let's smash it, with the limiter, compress it, turn it up, and then listen to the hi-hats. Suddenly, oh, you can hear them, or the shaker, you can actually hear it now better. And obviously I'm overdoing this just to demonstrate a point, but down here, you see these waves down here, that's the shaker. These waves down here, that's the shaker sound. You can see how much quieter it is. But look, down to where we were, way down here. And if I really blast it up, with the level. There, it's totally crushing our kick and snare, but you can see it reducing the dynamic range. So it's like it's raising up that quiet part of the sound. It's raising up that quiet part of the sound to make it easier to hear. So that is an example of the kind of thing that's done in making things loud in dance music using compression. We'll use a different example of this beat instead that's not so extreme. I'll use this one. And we'll blow it up the limiter. There, you can see that example of, you can see how the dynamic range is being reduced because we're pushing up the bottom, pushing up the volume, and then, in this case, limiting it, but compressing it, to really squeeze, really compress the range from the loudest to the quietest. And it makes all that stuff easier to hear, but if you really smash it too much, you'll hear it sounds bad, right? Yeah, because that the right balance of the dynamic range actually makes it easier to hear, and it makes it sound better because you do have some dynamic range between loud and quiet. So, yeah. So, anyways, moving on to the right balance of compression or limiting the max volume of a sound and then playing it back at an appropriate volume is the goal for dance music. A compressor allows that. You can play a sound loudly without the risk of peaks or volumes spiking up, and the sound can be safely adjusted to a high output level in the mix. And I've got just other examples of compressors here. We've got, what is this one? Oh yeah, this is the stock compressor of Ableton. The glue compressor, this is just got compressors that come in different shapes and forms, but they all do the same thing, like we're saying. So here, compressor. Here's where this is this kilohertz one that's free. Here's a threshold. You adjust the threshold here, adjusting your ratio here, the attack time, the release time, the makeup gain here. RMS, peak, or in this case fast, or in this one here it says expand. But so RMS is measuring the, here it actually tells you in this box right here, root mean square, where it RMS, where it measures, this RMS is measuring overall like average sound volume and reducing, and it's reducing, or crossing a threshold and reducing based on that, versus peak. Peak is a it scrolls through this thing here, but a peak is just looking for those peaks, the loudest points of the sound, and compressing based on that. So for example, you'll get different results from that, like using peak detection compression for punchy transient things like drums, versus using RMS compression for something smoother or more steady, like a vocal or a synth or something, where you're not looking for peaks and spikes in volume, really quick spikes in volume. You're measuring the overall volume of the sound and reducing based on that. So that's like practical application. Like RMS is more for like smooth, steady signals, and peaks are more for, peaking things like these drum beats or something. but they are just using different detection methods for the signal crossing the threshold of the compressor. And yeah, other examples of compressors here. Here's the M Audio one. You know, this one doesn't have, just has all the same controls here, and you can see just it's doing the same thing, but you know, just here's our input level here showing us, output level here, gain reduction here, R for reduction here. And our ratio control here, the threshold amount, the attack release, same stuff. This has a few other controls like saturation amount, compression amount. But yeah, you know, all like most plugins, they're all the same, you know, same thing, but same general principles, but you know, with subtle differences to them. So, oh yeah, here's the multi-band version of that. Multi-band compression is simply compressors that are split up in, that are treating separate bandwidths of the sound. So you can see here's the same compressor. This is just compressing the sound, you know, overall. And here's the same compressor, but split into these different bands, and you can adjust, you know, where low, medium, high. And you can adjust the placement of those bands. And essentially you just have 3 compressors, one on each band, that are treating that frequency range separately than the others. So this can give you a greater degree of control, because you can say compress the bass subfrequencies more or differently than the mids or the highs. However, as I mentioned in previous videos, multi-band processes are inherently destructive to your sound, because you are dividing the frequency spectrum into different bands. I mean, you're physically separating them into these different bands. So it's just something you want to be aware of and not overdo. That's why things like OTT compressor, you know, compression, if you just crank an OTT on something, it's like it actually makes it sound, you know, bad in a lot of cases. Yeah. For other reasons too, but yeah, that being said, the famous OTT compressor for over-the-top, OTT over-the-top compression is like this one, where you have high, medium, low bands, you know, adjusted, and then you've got different controls here. Like here, you've got the depth, the amount of the OTT compression being applied, you know, input gain, output gain. This multi-band and stuff like OTT uses what, you know, these ideas of upward and downward compression. This is like compression and expansion adjustments here that are a little more than we're going to get into right now. But yeah, you can see it's a similar concept here. You know, a compressor being applied to the high frequency mids or lows, and then adjusting those accordingly, adjusting the, you know, the slope of the compression. That as I've said before, like a good general rule, you can OTT and multi-band compression can sound really good. It's generally best used in parallel. I mean, like whatever works. You know, I'm not telling you, you know, it can't work sometimes, you know. But yeah, I mean, just listen to like what it sounds like if you crank this up all the way up to 100%. I mean, it really changes the sound. It's not like you actually want to do that, really. So something like, you know, 10% or something. You know, something modest, giving it a bit of that boost, a bit of that multi-band compression, where this is upward, downward compression and expansion. That's what these different bars indicate, and the crossing point here that you're adjusting the mix between those. That's where it's compressing but also expanding. So it's compressing, reducing the volume, but also expanding, boosting the volume of these different bands. That's why it can be very powerful and powerful sounding, but also, like I said, inherently destructive, because you're literally chopping your sound up into these 3 different parts, and you know, that can sound negative sometimes. But anyways, that's, you know, I think multi-band topics. But the concept of compression is the same. You know, here's another one, the poly squasher from Voxengo. Okay, so you got your threshold. Here you have a good visualization of the compression that's happening. See, if I turn the threshold all the way up, you'll see nothing. And as I reduce it, so there, you can see a visualization of the compression action happening there. Remember, like in the middle, this is the 0 line here. So as it's crossing that, it's being reduced in this visualization of the reduction happening there. Yeah, it's the same thing. And in regards to understanding, like, so you can pull up a EQ here and look at that and see, you know, if we go back to this one here. So remember, an EQ is a similar principle where the 0 is the line in the middle. This is 0. Anything above that is boosting the sound, the volume, increasing the gain, and below is reducing it, obviously. But, you know, look at the sound curve here and see what part of the sound, what is crossing that 0 line. In other words, what is going to cross that threshold line of the compressor and be compressed. In this case, it's really obvious because it's the kick and the snare, obviously, you know, but just looking at that and the EQ, you know, because EQ is just like a, you know, spectrum, you know, you can see here, you can see like, well, what, you know, the sound, when the sound is too loud, it's crossing the threshold and being reduced, but okay, what is crossing the threshold? What part of it is, you know, is going to be reduced? Well, in this case, it's the snare, which we'll see popping really loudly up here in the higher frequencies, and the kick drum, you know, which we'll see in the lows here. So that's just another part of it too, is like looking at, well, what part of the sound is going to be compressed, and how that, because that will radically affect, you know, your compression action. Like what if, you know, seeing here that the sub bass of the kick is obviously really loud. Well, what if I really reduced it, really turned it down? Well, then obviously that's going to really change the sound that is being processed by the compressor, because you don't have that loud sub bass that's going to be crossing the threshold first, essentially. And so that's part of the point of, you know, that's like multi-band compression, is you can treat those bands separately. You know, you could say that you know, it's different different parts of the sound are going to be treated separately. And yeah. Okay, we're going to get to side chaining, because now that we've gone over the basic functions of a compressor and understanding what it does and why and how it's being used, side chaining is a term, you know, we've all heard of and familiar with, because it's another very important thing. Mainly in mainly in electronic dance music, where things are being balanced to be very loud, and you want things like a kick to mix well with the bass. So sidechaining is just using an external signal to trigger the compressor rather than the sound that is being compressed itself. Easy example of that, I've got a kick here and a bass playing here. Switch over to that. So I've got a kick and a bass, and they're not compressed at all. You hear how this sounds. There, it's just a, you know, a kick and a loud steady bass note, just one bass note playing. And I turn the compressor on, and you can see the bass playing down here in the gray. And now, instead of just compressing the bass itself, I'm going to open this little side toggle over here and turn on external for sidechaining. And the source, I choose the source of the kick drum. And then, instead of the bass playing and shown down here in the visualization, you're going to see the spikes, you're going to see the kicks playing, and then we adjust the threshold and the compression action based on that input, that sidechain signal. And you can see those waves like that of the bass being compressed, being reduced in volume, and then sloping back up. And that's what gives that classic pumping sound of, dance music, of the kick sidechaining, compressing the bass. And this gets into creative usage as well, where rather than just reducing the sound, like keeping it from being too loud when you're compressing the sound itself, sidechain compression, you are often using this as a creative shaping tool, giving it a rhythm, or reducing the sound, at least just so that the kick or the snare or something has space in the mix to be heard. Because as you see, as we're reducing this bass sound here, it's giving space in that sound. It's giving space in that time for the kick drum to be heard, And you see there's a good example of that. So you have RMS mode is listening to the overall volume of the kick, and it's giving it this very different curve than if I switch to peak mode, because again, peaks, it's listening just for these max volume peaks of the kicks, and you see it's a much more sharp curve. Yeah, and you see that's where the attack time and the release time, especially, the release time is dictating how long that curve slope back up to zero is going to be. And so that will have a strong effect on the sound result. And that's where it's done as a more of a creative sound choice. And yeah, that's an example of sidechaining. This can also be done just as a creative choice too, where you can have something else, like say, if I took this, well, your sidechaining to a kick is an easy example, but you can sidechain to anything. You can create just another track that is silent, but it's just playing a rhythm to sidechain here. Like I'll use that example of this shaper box in compression mode, because the shaper box is a multi-tool where you can do all these different things. But volume here, it has a compressor function as well, which is just another compressor, but it also has a volume function here too, a volume automation. And remember, volume automation really is what compression, especially sidechain compression, is actually just doing. So if we have a blank MIDI track here, I've got a MIDI track with nothing and just a pattern playing on it here, but then the output is being sent to this bass and into the shaper box here, then we should see it. Come on. Oh, there we go. I see the wave over there for some reason. But anyways, the timing of it, the slope and the timing of it being adjusted that way. No MIDI detected. What are you talking about? It's getting MIDI. Come on. MIDI to serum. It's like, well. Oh, it's not turned on. Okay. Yeah. MIDI channels those to be turned on. Okay, there we go. So now we've got our sidechain happening just from this MIDI trigger, but then I can make this MIDI trigger whatever I want. I can make it double time, you can use sidechaining as a creative effect, just creating, whatever kind of pattern you would want. I'm just making random examples in this case, but, Yeah. So yeah, sidechaining. it is a big deal, and we've heard about it a lot because it is very useful as both a functional mixing tool of sidechaining like your kick, snare to your bass to the rest of your track, etc., so that the drum hits have space to be heard in the mix and punch through. It also has creative applications like this, where you can just use it just to give something a rhythm, and shaping the bass of, just you have just a steady bass playing just like this wah sound, but then when you give it that sidechain pump, it really changes. It can be a big part of writing your bass line, where it gives it that movement, playing off the kick and stuff. So, yeah, that's basically it. Going over the function of compressors, where, again, they are monitoring an incoming signal and reducing their gain or volume by a certain ratio amount when it crosses a certain threshold level that is set. This helps maintain the volume limitations that you desire. Can basically turn things down when it gets too loud. It can also be used to reduce the dynamic range between loud and quiet parts of the sound, and therefore squeezing it, compressing it, and then also increasing the output level to make it all louder overall. This can be done to taste, or to extreme, to really, what they call smash things and make it very loud, like in drum and bass or something. Or just tastefully when you want to just bring up the quieter parts of a vocal or a guitar or something and make sure it's audible, but then if you just turned the volume up, you would get these peaks over zero of the loud parts, so you compress it, yeah, or it can be done in an extreme sense, like a limiter, where it's just chopping it off, it's clipping the signal. You can really boost the signal louder without having it go over zero at all. And that's part of the mastering process, where they are maximizing the audible volume of the whole track, but yet clipping it off at zero so that it doesn't, peak and go over the zero crossing limit. And then, yeah, sidechaining, where it can be done creatively, functionally and creatively, to give space in your mix for your drums to come through or something, or creatively to help shape a bass sound, or give rhythm to different things. Yeah. Those are the general principles of compression overall. Obviously, like most things, it has a lot of nuance and, and more mastery that goes into it. And there are different types of compressors that offer different sound characteristics. That's another, topic, that essentially there are compressors that react differently to different types of sounds. Not going to go all into that right now, but the function of all these different compressors are essentially the same. Like we talked about, they all have these shared parts of the threshold, the ratio, the knee, the makeup gain, a side chaining, external trigger ability, and so forth. So yeah, I hope this helped clarify an introduction to compressors. They are a very useful and powerful audio tool. They get a lot of, talk about them for a reason, of course, and they are a big part in things, especially like dance music. So, yeah. Well, thanks for bearing with me for this this video. Yeah. Thanks. As always, if you have any questions and stuff, let me know. And yeah, we'll see you in the next one. Thank you.